Welcome, learners. In this video, we will talk about the basic syntax and data types in Solidity. Let's start by basic syntax. Solidity is a programming language specifically designed for developing smart contracts on the Ethereum blockchain. It is a high-level, statically typed language with the syntax and features similar to those of JavaScript, C++, and Python. So Solidity used to write self-executing smart contracts that can control the transfer of cryptocurrencies, digital assets, or other valuable items based on predefined rules and conditions. Actually, Solidity support various types of the data, such as integers, strings, boolean, and arrays. And it allows for control structures such as if-else statements, loops, and the switch statements. It also supports object-oriented programming features such as inheritance, polymorphism, and encapsulation. So Solidity contracts can be compiled into bytecode and deployed on the Ethereum blockchain for execution. Providing also a secure and decentralized way to execute code without the need for a central authority. Let's start with the basic Solidity program to understand the syntax of Solidity in this example. At the first, we have a compiler directive. A program is a compiler directive in programming languages that provides additional information to the compiler or interpreter. It helps to control the behavior of the code, such as language, version, optimization options, or warnings. In Solidity, a programmer, is used to specify the compiler version that the code should be compiled with. This is important because Solidity is a rapidly evolving language, and new versions may introduce breaking changes or improvements that affect the behavior of the code. For example, in this code, programmer directive that specifies a version of the Solidity compiler should be used is, as you see here, this part of the programma, of the pragma directive specifies that code should be compiled with a Solidity compiler version equal to or higher than 0.6.12, but less than 0.9.0. This ensures that the code is compatible with the latest version of Solidity, but doesn't break if a new version with the breaking changes is released. About contract, in Solidity, contract is a collection of functions and variables that are written to be deployed on the Ethereum blockchain. Contract can be thought of a self-contained program that can interact with other contracts and the outside world. So this line, contract hello world, declares a contract hello world. About the variables, the third is basic syntax here is in Solidity, we have variables to store data that can be used later in the program. There are different types of variables like uint, uint unsigned integer. We have also string, bool means boolean, and so on. The line here, uint a, declares a variable a, okay? The fourth basic syntax is the functions. Functions in Solidity are similar to functions in other programming languages. They are used to perform specific tasks or operations. So the line here of function set and function get public, this one, function get public view returns, and function set uint x public are two functions to set and get the value of the variable a. About the Solidity data type, Solidity is statically typed language, which implies that the type of each of the variables should be specified. Data type allow the compiler to check the correct usage of the variables. So the declared type have some default values called zero state. For example, for bool, the default value is false. Likewise, other statically typed languages, Solidity has value types and reference types. Okay, so also in addition, types can be interact with each other in expression containing operators, and the concept of undefined or null values doesn't exist in Solidity, but newly declared variables always have a default value depend on their type. Like I said, Boolean, the default value is false. Solidity provide various data type to work with. Let's explore them. About the value types, the first type of the in the Solidity, we have here Boolean, integer, fixed point numbers, address, and bytes and enums. About the Boolean, as you see here, represent true or false values. Integer used for storing the whole numbers, while fixed point numbers are not fully supported yet. About the integers and Solidity, we should carefully about that it's restricted to a certain range. For example, with uint 32, this is 0 up to 2 to the power 32 minus 1. The next type of value types is address. Address used to represent Ethereum addresses and perform balance-related operations. Now let's talk about the bytes. Bytes store fixed size character sets, while a string, we will talk about it in the next slides, store variable length character sets. Let's talk about the bytes. Bytes in Solidity is considered a value type and used to store fixed size character set. It's similar to the string type, but there are some important differences. Be careful about that. While both bytes and the string can store character data, the key distinction lies in their length and storage behavior. The bytes type has a fixed length ranging from 1 to 32, whereas the string type has a dynamic length, allowing it to store a character set equal to or greater than a byte. One advantage actually of using bytes over a string is that consumes less gas and Solidity. Gas is a major of computational effort required to execute operations on the Ethereum blockchain. So by using bytes, when we know the length of the data we are working with, we can optimize gas usage and make our smart contract more efficient. So it's important to note that when working with bytes, you need to be aware of the fixed size and ensure that your data fits within the specified length. If the data exceeds the allocated length, it will be truncated. So to summarize, bytes in Solidity is a value type used to store fixed-sized character set. It offers the advantages of lower gas consumption compared to string. When the length of the data is known, by understanding these differences, developers or you actually can make informed choices regarding the appropriate data type to use in their or in your Solidity contracts. The next type in the category of value types is enum. Enums allow us to create custom data type and assign names to integral constants. So again, the enum type is considered a value type and is used to create user-defined data types. Enums are particularly useful when we want to assign a name of integral constants, making our contracts more readable, maintainable, and less prone to errors. An enum declaration defines a new type, and its options represent the possible values that a variable of that type can take. The option of enum are represented by unsigned integer values starting from 0 and incrementing by 1 for each subsequent option. As you see here, an example of how to define and use an enum in Solidity. In this example, we define an enum called day of week with 7 options representing the days of the week. So by default here, the first option, Monday, okay, is assigned the value, the value here is 0. The second option is Tuesday, is assigned the value 1, and so on. So enums can be used to declare variables and function parameters, allowing us to work with these named options. For example, here, contract, example contract. In this contract, we have a public variable, current day. This is a public variable of type day of work. Here, enum, the name of enum here is day of week. So here we have a public variable with the type of what? Day of week, which can hold one of the enum options, okay? So here the set day function allows us to set the value of current day by passing a day of week option as an argument, okay? We put it here as an argument option, okay? Enums provide a convenient way actually to represent a finite set of options in our contract, making the code more expressive and self-documenting actually. They are widely used for scenarios where a variable can only take a limited number of predefined values. That's a brief overview of the enum type in Solidity. In this example, the contract types initialize the values of different types of values. So we talked about the type of value. We have integer, we have boolean, we have address, bytes, enums, okay? So in this example, this code is a smart contract that demonstrates various value types in Solidity. Let's go through it step by step. About the first line, SPDX license identifiers, this line is a special SPDX identifier that specifies the license under which the contract is released. So in this case, it is the GNU, this means General Public License version 3.0, okay? About the next line, Pragma Solidity, this specifies the version of Solidity that is compatible with the contract. In this case, it specifies that the contract can be compiled with any version equal to or greater than 0.4.22 and less than 0.9.0. The next 3 lines, these are comments, okay? They provide information about the contract. Here at title, specifies the title of the contract. At author, also specifies the author's name. Notice provides a brief description of the contract. About the contract types here, this line starts the contract declaration with the name types. Bool public boolean equal false. This line declares a public boolean variable named boolean and initialize. So here we have the name of variable. It's boolean and initialize it with the value false. And the next int 32, this line declares a public 32-bit signed integers variable named int var. So this is the name of variable and initialize it with the value, as you see here, minus 60313. Okay, the next line is string public. This line declares a public string variables named str and initializes it with the value as you see here. The next line about declares the public byte variable named B and initializes it with the value A. Bytes in Solidity represent fixed size sequence of bytes. The next line about define the enum named my enum, okay, with the three options as you see here. Function enum, this is a function named enum defined to return value of the my enum type. It returns the option geeks. So overall, this contract demonstrates the usage of different value types in Solidity, including Boolean, integer, strings, string, byte, and enum. It showcases how these types can be declared, initialized, and used within a contract. Next, here we have reference types in Solidity. These include arrays, strings, struct, and mapping. So reference type variables store the location of the data. They don't share the data directly. With the help of reference type, two different variables can refer to the same location where any change in one variable can affect the other one. Let's talk about array as the first type of reference types. Arrays store a group of variables of the same data type, allowing access through index locations. Array are data structure that store the fixed collection of elements of the same data type in which each and every element has a specific location called index. Instead of creating numerous individual variables, the same type, we just declare one array, okay, of the required size and store the elements in the array and can be accessed actually using the index. So in Solidity, an array can be of fixed size or dynamic size, and we will talk about it in detail in the following videos, inshallah. Arrays have a continuous memory location where the lowest index corresponds to the first element, while the highest represent the last. Now let's talk about the strings. Strings in Solidity is a reference type of data type which stores the location of the data instead of directly storing the data into variables. They are dynamic arrays that store a set of characters that can consist of numbers, special characters, spaces, and alphabets. String in Solidity store data in UTF-8 encoding, and like JavaScript, both double quote, and the single quote can be used to represent strings in Solidity, as you see here. We have here a double quotation and here a simple quotation. Now let's talk about a struct. A struct in Solidity allows you to create more complicated data types that have multiple properties. So you can define your own type by creating a struct. They are useful actually for grouping together related data. Struct can be declared outside of the contract and imported in another contract. So generally, it is used to represent a record. So to define a structure, struct keyword is used, which creates a new data type. About the mapping, in Solidity, acts like a hash table or a dictionary in any other language. These are used to store the data in the form of key value pairs. A key can be any of the built-in data types, but reference types are not allowed, while the value can be of any type. Mapping are mostly used to associate the unique Ethereum address with the associated value type. Thank you for watching. Stay curious and keep coding.